Bienvenue à tous. Welcome everybody for the Henry G. Friesen International Prize in Health Sciences lecture. And this is actually the 2020 lecture, but as with the Olympics and other things, we're having it in 2021. But for those of us in the room, it's a real privilege to be here with actual three-dimensional people. And that's going to make this an even better lecture than it would be otherwise. Before beginning, it's very important that I acknowledge that McGill is on land that has long served as the site of meeting and exchange among Indigenous people, including the Haudenosaunee and the Anishinaabe peoples. And we acknowledge and thank the diverse Indigenous peoples whose presence marks this territory on which peoples of the world now gather. It's always a pleasure to be able to host a Friesen lecturer. This is both an opportunity to honor one of McGill's great professors, Henry Friesen, as well as to welcome a world-class person like Dr. Walport. Before going any further, I'd like to ask the Principal and Vice Chancellor, Suzanne Fortier, to say a few words.
Merci David et bonjour à vous tous. Merci d'être ici avec nous aujourd'hui. It is my great pleasure to welcome you to the Henry G. Friesen Annual Lecture in Health Research. Et c'est vraiment un grand honneur d'être parmi vous aujourd'hui afin de reconnaître l'excellence de chercheurs les plus éminents dans le domaine des sciences biomédicales. The lecture's namesake, Dr. Friesen, is known for his many contributions to Canadian universities, and as David just mentioned, including our own when he was a professor here. But he's also recognized for his contributions to patients and to health science research, the whole community of health sciences researchers worldwide. Dr. Friesen brought together scholars, scientists, practitioners, governments, industry, and patient groups. He was both an architect and a champion for an audacious and innovative vision for health research. And I remember talking to Henry when he was telling me that he had arrived in Ottawa as a fairly shy person and found his way to be very close to influential people in Ottawa to really convince them that we had to change our research model in Canada for the health sciences. And he was so effective in his humble way that, of course, he did revolutionize health research in our country. I think it's a tribute to his character as well as his great success. It's really a great privilege to welcome Sir Mark Walport to McGill today. He is, as David mentioned, the 2020 Friesen International Prize in Health Sciences, and he will be delivering the Henry G. Friesen Annual Lecture in Health Research. And I know we all look forward to your presentations, Mark, because, of course, we know for sure that we will learn from your experience, but also your insights, and particularly at this time when we are still facing a major global crisis. So I would like now to introduce Dr. Abi Angel, who will be introducing the speaker. Dr. Angel is a leading endocrinologist, professor emeritus of the University of Manitoba, and senior fellow at Massey College. Dr. Angel is the founding and current president of the Friends of the Canadian Institute of Health Research and the 2021 winner of the Research Canada Leadership in Advocacy Award. Dr. Angel.
Merci, Madame la Principale. C'est un grand plaisir d'être ici, à McGill University, et participer dans le forum public Prix Friesen 2021. Thank you, Principal Fortier. for welcoming us, Dean Eidelman and Martha Crago, who can't be here today. We're just delighted to participate once again with the Friesen Prize, a lecture here and presenting to you Sir Mark Walport. This is a brochure that is a promotional brochure and membership brochure, but it features young people. It's our original brochure, and it emphasizes the point that the future of science depends on the next generation of scientists and young people. And I'd just like to emphasize the fact that these young people have had a year or almost 2 years stolen from their experience in their socialization, but we are focused on encouraging, retaining, and supporting this group, and we highlight the fact that our Friesen Prize winners spend significant time with students in their travels. All are welcome to join Friends of CIHR, so feel free to seek an application. Friends of CIHR, now in its 21st year, actually 24th year, if you count the predecessor organization, Alumni and Friends of MRC. It was under the guidance of Henry Friesen that we established the Friends of CIHR in an attempt to establish a advocacy group on behalf of the community of scholars, former awardees, and young people associated with MRC, and that's why Friends of CIHR was born. Its purposes include the promotion and values and ideals of CIHR, to communicate research, communicate knowledge and accomplishments to the informed public, and also to recruit and retain young people and trainees in the health sciences in support of their careers. Now, to achieve these goals, in 2005, coincident with the creation of the Canadian Academy of Health Science, we established the Henry G. Friesen International Prize. And this year, of course, we have Sir Mark Walport as our 2020 prize winner, and we are delighted to have him come to McGill to meet students, scientists, academic leaders, and to share our ideas. We're, of course, delighted with the fact that McGill University has been a sponsor of the Friesen Prize program since its inception. Sir Mark has done his duty so far, and I'd like to point out that this is the end of a week of interactions between Friesen Prize program and institutions in the country. And in Toronto, he gave his Friesen lecture, ran a roundtable, made a trip to Waterloo University for a day, and spent a half day with Toronto Sick Kids Hospital before coming to McGill as the bookend of the event, and we thank Sir Mark for his endurance. Now, Dean Eidelman will be giving the more formal introduction to Sir Mark, but I'd like to read the citation on his prize certificate just to indicate why he was selected as the 2020 Friesen Prize winner. A visionary health research planner and advisor who championed fundamental science in health, research, engineering, technology, and innovations. That's the basis of the prize that was awarded to him. Next slide. I'll do it. This is his picture. And I'd just like to acknowledge the sponsorship that exists across the country of the prize. McGill there is in red, a major sponsor, as usual, and the other institutions in the country that participate. I'd like to point out that CBC Radio has also been a partner to this because he is featured on the program Ideas, as have others, every year. Now, it's also an opportunity for me to tout in this panel of prize winners over the years, and you read very distinguished names here. And the significance to me is not only the great talent that's here that now includes Professor Sir Mark Walport, but the number that have a McGill affiliation, the number that have been here to McGill as Friesen Prize winners, and in other capacities. And so Bartha Knopper, David Naylor, Alan Bernstein, Janet Rosent, so forth. And familiar names, Mark Tessier-Levine, Victor Zhao, John Evans, and Joe Martin. This is family to this institution. So we're absolutely delighted with that. And it represents the very best of the very best internationally. One of the things we added into the Friesen Prize program about 6 years ago was a series of policy roundtables. The purpose of this was to help gather together expertise in the community that a prize winner visited, to help focus discussion and amplify the messages of the Friesen Prize winners. And if you look at the titles and themes of our roundtables, you will notice a very common pattern. All these relate to the life and interests and concerns of the next generation of scientists. And it's a useful enterprise because it collects together local expertise to meet with and discuss issues of the day with the prize winner, and thereby establish a link, share knowledge, and as often as not, develop some sort of consensus. And what we do with this information, this experience, is publish proceedings, which is available on our site. And you'll notice 2021 Pandemic Preparedness, Science Informing Policy, that represents the activity today that Sir Mark led. And Alan Evans, thank you very much for hosting and leading that activity. Now, the Friesen Prize winners have an impact beyond simply coming and giving lectures. One of our programs is the Video History of Medicine project, and one of our key subjects was Brenda Milner, a legendary figure in the world of neuropsychology. And this is the plate of her life history that Michael Bliss recorded, 3 CDs with 90 chapters of her life story. I pay tribute to this for a very specific reason, talking about impact. It turns out that a young gentleman named Trevor Barrett, an actor and filmmaker, received a Canada Council grant to develop a musical about her life. Talk about an impact of Brenda Milner through Friends of CIHR, through the Video History of Medicine project, and this experience. This is an impact completely unexpected, but something that we'll all be proud of and look forward to. I thought that was very, very novel. Well, this is just the beginning of the day, and I don't want to encroach further on Sir Mark's time, but I'll request just a few minutes at the end for a couple of special announcements, if you don't mind, and I'd like to invite Dean Eidelman now to come and speak.
Thank you, Abhi, and it's an honor and a privilege to introduce Sir Mark Walport. So, as you can gather from Dr. Angel's comments, he's known for many great accomplishments in science. But to start off, I'd like to say what first impressed me, I only met him just now, but what impressed me by reviewing his CV and so forth, is that he was sort of the consummate clinician scientist in the first part of his career. He was trained, first he did medicine at Cambridge at Clare College, and then went on to train at Hammersmith and Guy's and the Brompton, and then went on to a career at Hammersmith in rheumatology. He did a PhD at Cambridge as well, and went on to become very internationally recognized for his work on the immunity of lupus erythematosus. But that alone would be enough of an accomplishment, and he certainly has been honored for that. But he's really made a significant impact as a champion for science through a series of positions he's held in the United Kingdom. Most notably as director of the Wellcome Trust, which is a well-known global charitable foundation dedicated to human and animal health. He supported and oversaw the UK Biobank project. He was responsible for overseeing the completion of the Diamond synchrotron and a number of other major projects and international partnerships, including the Wellcome Trust, DBT India Alliance, an independent charity that funds research in health and biomedical sciences in India. He was named the Chief Scientific Officer to the UK government from 2013 to 2017. And during that, of course, he helped steer the course of issues of science and technology. From 2017 to 2020, Sir Mark was the Chief Executive of UK Research and Innovation, an organization that unites 7 disciplinary research councils responsible for research and knowledge exchange of higher education institutions in England, and the UK's innovation agency, Innovate UK. And just parenthetically, I'd like to, as an editorial remark, say the idea of uniting all the councils in this way is, I think, one of the great moves that the UK has done that we would be well advised to consider here in Canada. And among his other contributions, Sir Mark has served as founder fellow and first registrar of the Academy of Medical Sciences. He's been a member of the Advisory Board of Infrastructure UK, a member of the India-UK CEO Forum and the UK-India Roundtable, and a non-executive member of the Office for Strategic Coordination of Health Research. So all of these accomplishments have led to him being knighted in 2009 for services to medical research. He was elected a Fellow of the Royal Society in 2011 on the basis of his scientific contributions, and he was named an Honorary Fellow of the Royal Society of Edinburgh in 2017. So altogether, we have really an outstanding individual with who's had many great accomplishments and who's really been transformative, particularly in the UK and also internationally, and clearly well-deserved for this honor of being the Friesen Lecturer. And so without further ado, Sir Mark.
I'm resting my paper on the laptop, so it'll be very interesting to see which buttons get pressed accidentally. So Principal Fortier, Dean Eidelman, Professor Angel, thank you very much indeed. And it's a great privilege to be here this afternoon. And indeed, it used to be an adventure to cross the Atlantic, and then it became rather straightforward. It's now a bit of an adventure again, but it was worth it. And it really is a great pleasure to be here this afternoon. So, I suppose the last few years of my career have brought me right into the crucible, as it were, of policy making for science, engineering, technology, the social sciences, the arts and humanities in the UK. And I've learned a great deal about the interface between the research endeavour and policy making. And in my time at the Wellcome Trust, I was very concerned with policy for science. But as the government chief scientific advisor, the main role is about science for policy. And the first point I want to make is that I'm talking about science, and people talk about STEM, and they talk about science, technology, engineering, and mathematics. And there was a famous lecture by a public policy maker and academic called C.P. Snow, where he talked about the two cultures. I don't think that we should perpetuate a myth of the two cultures, and I think we should be talking about STEAM. I think it's science, technology, engineering, the arts and humanities, and mathematics. And I think that the social sciences have been and will continue to be at least as important as the natural sciences when we come to handling not only the pandemic itself, but it's the aftermath. Because, of course, the lives of many have been disruptive, many by the virus, but many by the indirect effects of the virus on, for example, deprivation of education, loss of work, all the economic consequences, and all the misery of social disruption, because we are social species, and though cooped up in a single parent with children in a high-rise block, it has been a pretty difficult time. And science it's the social sciences and government policies that are going to be critically important. Public awareness of the relevance and importance of science is at a quite extraordinary level. And we will all agree that it has been a pretty peculiar couple of years, and ironic in a way that it's just after the centenary of the last really major global pandemic, which of course was the 1918-19 flu pandemic, which killed more people than had been killed in the Great War. And of course, at that time, people had no idea what the cause of influenza was, and a bacterium, Haemophilus influenzae, got its name because it was thought to be the cause of influenza, which of course it wasn't, although it is a significant respiratory infection. And the public have become aware of science, and I talk about the UK, but I think it's probably very similar in Canada and in many other countries around the world. Perhaps not quite in the way of having press conferences from number 10 Downing Street with the Prime Minister flanked by his chief scientific advisor, Sir Patrick Vallance, also a physician who has taken the role during this time. And I think he wasn't quite expecting this when we had discussions about what it might be like to be the government chief scientific advisor, and also the chief medical officer, Professor Chris Whitty, both very close colleagues over many years. But we had on television the sorts of PowerPoint presentations that you might have seen in an academic seminar with lots of graphs. Next slide, please. You're on mute. That was mainly the journalists trying to ask questions, I have to say, and who muted them is anyone's guess. But reproduction number, people developing an understanding of exponential growth, scientific models being presented, though sadly scientific models provide projections, but they were often confused with providing predictions, which of course they do not, because they have a lot of uncertainty and lots of different scenarios. And of course, when people make policy decisions based on possible scenarios, and for example, the number of cases is lower than might have been projected, people say, you were wrong, but they weren't wrong, of course. It was the policy that was introduced. And a committee, which is part of the hardwired system for providing advice to government on all the sciences, SAGE. I normally hate acronyms, but SAGE is actually rather a good acronym. It stands for Scientific Advice Group in Emergency, and it tries to be SAGE, became a household name. And I think if ever one wanted a justification for discovery research, then the coronavirus pandemic provides it. So actually imagine this pandemic in 1918. Very nasty virus indeed, much worse than influenza actually. And imagine also if we hadn't had modern technology. Just imagine this pandemic 25 years ago without the developed internet that we have now. It would have been a very different pandemic indeed. And one thing that hasn't gone wrong, and therefore people aren't really aware of it, is the fact that all of the other infrastructure on which modern societies depend has kept going. So the lights haven't gone out. Heating has continued. And I don't imagine that Montreal would be a very comfortable place in the absence of heating, at least at this time of year. And I think that, as I'll say in a minute, governments, countries are very good at managing the last disaster. They're not necessarily best prepared for the next disaster. And one of the things that this reminds us, I think, is that having a national risk register and thinking about how one should use it to prevent things happening in the future, as well as managing in the event that it does happen, is absolutely critical. And it is our infrastructure that poses huge threats. And we've seen disruption to supply lines. What happens actually when a major tanker gets stuck in the Suez Canal blocking it? Unfortunately, it was possible to release that, but we're dependent on, societies have become very much more efficient, but in doing so less resilient. We depend on just-in-time supply lines to an extraordinary extent. But so it was, going back to the importance of discovery science, Friedrich Miescher describing nuclein, which of course was nucleic acid, the work of Avery and MacLeod on the McCarthy and MacLeod talking about transformation of pneumococcus, the structural work on DNA, the work of Fred Sanger in inventing methods for sequencing DNA and RNA, and all the work that was preparatory to preparing the vaccines, the RNA technologies, all of this was discovery research. And we will continue to need discovery research, and I think this is an important opportunity to remind policymakers and keep reminding them of its importance. And so, because of all this science, we had the sequence of a completely novel virus in humans within a matter of weeks, thanks particularly to the openness amongst the genomics community, who communicated a sequence which politicians might not have allowed to happen, actually, very, very quickly. And of course, the sequence leads you to the diagnostics in a matter of weeks. We've ended up with very large clinical cohorts. And one of the messages of my talk is be prepared, because actually it was because there were groups such as ESARIC, the International Severe Respiratory Infection Consortium, which was up and ready to go. We had vaccines developed in record time, using novel technologies, which under normal circumstances would have taken years to be widely implemented. And clinical trials done again collaboratively, both nationally and internationally, which led to the development of new treatments and showing that cheap drugs such as dexamethasone could reduce death, and that drugs beloved of certain individuals where there was no evidence, such as hydroxychloroquine, did not work, and indeed were potentially very harmful indeed, particularly when taken in overdose. But in spite of all of this, there is still much that we don't know about coronavirus. And much of the science advice throughout has been as much about the uncertainties, and the models offering those projections under different scenarios have included wide confidence levels. And this turns to one of the key questions about communication. The media does find it difficult to present uncertainty as just that. What it prefers to do is to present two or sometimes more people with opposing opinions. And these are all too easy to find. Particularly in broadcast media, the very short time of interviews, coupled with the desire to present diverse views, means that nuance is extremely hard to communicate. And in the face of differing views, how do people decide who it is they should believe? And it shouldn't be a beauty contest between two people presenting different things. It should be actually about, in a sense, recognizing the uncertainty. And I think the other thing, which is really important, which is in spite of outstanding science and in the UK very sophisticated embedded mechanisms for scientific advice, nevertheless, we and other advanced scientific countries have ended up with some of the highest death rates in the world. Though, of course, I think it's also fair to say there's a lot we don't know about true death rates from COVID-19 in many countries, because we have the fortune of living in countries which have very good and honest, as it were, vital statistics. So there are some big unknowns there as well. But leaving aside any uncertainty, there is no doubt at all that some of the highest death rates in the world have occurred in some of the richest countries with highly sophisticated health systems and scientific infrastructure. And the USA has the richest scientific infrastructure of all, but I think also probably has one of the most unequally distributed healthcare systems. And I'll come back to that. So what are the reasons for the bad outcomes in rich democratic countries? And the first of these is that it's the political nature of liberal democracies that strongly conditions policymakers against restricting the liberty of people to mix freely. So it's very countercultural in democracies to restrict people's liberties. But coronavirus doesn't care much about policies per se. Well, it cares about policies if they make it difficult for it. But so the coronavirus likes simply the opportunity to jump freely from one human to another, which it does in crowded environments with poor ventilation. And so I think in many countries, including the UK, a reluctance by policymakers to restrict people's liberty led to some late decisions and therefore greater and earlier growth and spread of the infection. But I think there's another important lesson that we have to learn, which is that we take for granted a world of clean water, safe food, good medical care, and certainly until now effective antibiotics. And those have shifted the focus of public health in our countries away from the prevention and management of infectious disease towards the prevention and management of chronic conditions such as obesity with associated diabetes, cardiovascular disease, cancer, and all the other chronic diseases. And I think it's fair to say that countries that have experienced significant epidemics of serious infectious diseases in recent years, in general, have been much better prepared for the coronavirus pandemic. And it is my point that we are better at managing the last emergency than the next one. And I started in 2013 as the government chief scientific advisor, and we had quite a prolonged period of very serious floods. And after that, it became quite difficult to persuade policymakers that we should also worry about the potential for drought, which is an issue in some parts of the country, particularly the southeast of England and East Anglia. And so people aren't, it's just the cognitive biases we have, that we deal with our past experiences and we sort of slightly discount future potential catastrophes of a different sort. So I think the most important lesson possibly from the coronavirus pandemic is that we simply hadn't paid the insurance policy to maintain really good infection control. And frankly, insurance is intended to stop you ending up paying a large bill, and we've ended up with a very large bill. So turning more generally to the role of science advice for public policy, because in spite of its salience, this really isn't a talk solely about COVID-19. I think the really important point of principle is that the job of a scientific advisor is to provide evidence to help policymakers make decisions. And I used to constantly get questions, don't you get frustrated if the politicians don't take your advice? And the answer was, no, because at the end of the day, they're elected and I'm not. And what I would say is that they always listened respectfully to what the evidence showed and what the uncertainties was, but they didn't always do what I might have done if I'd been elected a government member, but I'm not. And I may return to that as well. So it's really important that we recognise that the policymakers in democratic societies are the politicians that we elect, who form the government, and so very specifically the ministers who are individually and collectively are responsible for governing the country. So, wind back a few years. In 2012, I'd been the director of the Wellcome Trust for almost 10 years. I had become increasingly involved in matters of science policy and in contentious issues such as research involving animals, the use of technologies around in vitro fertilization, the use of medical data, and I'd been a member of the Prime Minister's Council for Science and Technology since 2004. And so I'd become involved in scientific policy making. And because of that, in a way, the opportunity arose to become the chief scientific advisor to the government. And this is a role whose history dates back to the Second World War, when science advice was absolutely crucial to the outcome. And indeed, the truth is that there's a long history of warfare as a stimulus for investment in science and its applications. And indeed, there's nothing quite like an emergency, and of course COVID is an emergency, to stimulate innovation and to liberate people from the bureaucracy that has the potential to stifle creativity and risk-taking and to slow down progress. And in fact, interestingly, a historian called David Edgerton wrote a book on the history of science in the UK, which he called Britain as a warfare state. And his point was, and he was contrasting with Britain as a welfare state, that actually, and it's true around the world, that the mechanisms, the events that led to the funding, the large-scale funding of research and innovation from the public purse, really came following the, arguably it goes back to the Crimean War and the work of Florence Nightingale, but certainly the First World War and the Second World War. So the research councils, which have finally morphed into UK research innovation, emerged from the furnace of the First World War, and in particular a report by Richard Burden Haldane, who was a great philosopher, but statesman and politician, who published a report in 1918 on the machinery of government. And he made the point in that report that he thought the government would operate better if it used evidence. And I think we can all agree on that. It was a very good report, and it set the tone for the model of the government ever since. But he also was responsible in a way for the foundation of the modern research councils, so the Medical Research Council, which started just before the First World War as the Medical Research Committee, and the Department of Scientific and Industrial Research, which was a combination of the Innovation Agency of the time and also the physical and sciences as well. And of course, after the Second World War, in the United States, it was Vannevar Bush who was the president's scientific advisor, and that led to his great report and Endless Horizons, his various writings, led to the foundation of the National Science Foundation. And I think if you look at the history of Canada's scientific funding agencies, they all arose at roughly the same sort of time with the same stimuli. So, after the war, the most senior scientific advisor in the UK government was located in the Ministry of Defence until 1964. And again, that just makes the point as to where the science had been so important. But in 1964, the chief scientist was actually an anatomist, Sir Solly Zuckerman. And he converted his role from being CSA to the Ministry of Defence to become the first chief scientific advisor to the government. And so it was in 2013 that I found myself as the 11th government chief scientific advisor, which is a Whitehall permanent secretary reporting to the cabinet secretary and to the Prime Minister and head of the Government Office for Science. So as in Canada, we have a sort of civil service, and the contrast with the role in the United States is that it's an appointed member of the administration, whereas I was a civil servant, and as such, if the government changed, the civil service stays the same. Whereas the administration changes in the States. And I think the model in Canada is the same as the model in the UK. So the job description for the government chief scientific advisor is precise, whilst being extremely vague in its interpretation. Simply, it is to provide advice to the government on all aspects of science, engineering, technology, and the social sciences for all of government policy. So it's a sort of small job. But like most jobs near the centre of government, it's a job that's heavily influenced by events, especially emergencies where science can help. So it is biological, geophysical, and human-created emergencies that have defined the tenure of a number of government chief scientific advisors. And I think it's fair to say no more so than Patrick Vallance, who's had the hardest job of all of us, I think since the creation of the role, actually. To deal with, who's had to deal with the first really severe global pandemic. But Bob May had to deal with bovine spongiform encephalopathy. Very, very difficult, because the science and the uncertainty around it was so enormous. Vast amounts of uncertainty. I mean, much less was known about what was going on in BSE than with a viral infection or bacterial infection, which we know a lot about. David King had to deal with foot and mouth disease. And John Beddington, my immediate predecessors, had two geophysical events. So the volcano in Iceland that erupted, Eyjafjallajökull, and of course the problem that caused with flights crossing the Atlantic, and politicians who were very keen to maintain transatlantic flight, but airlines that weren't so keen in having their jet engines inactivated in midair. And there was a well-known example of an aeroplane flying over a volcano in, I think, Indonesia in the Far East, whose engines all cut out as it went through the volcanic cloud. And fortunately, it went into dive and the engines restarted. But you can't always guarantee on that happening. And in my time as government chief scientist, I had to provide advice on flooding, which occurred on a number of occasions, Ebola, Zika, and an earthquake eruption in Nepal. But it meant actually that my time was much less dominated by emergencies, and I was able to provide more strategic advice to the government on emerging technologies. And an important role of the chief scientific advisor is to act as a transmission mechanism between the outside world of science, engineering, technology, etc., and the inside world of government. And so we demystified technologies such as quantum technologies, distributed ledger technologies, AI, because if policymakers are going to be able to support them, then they need to understand what the potential of the technologies are, both good and bad. And a great deal has in fact changed in government science advice since the time of Lord Zuckerman. It's become much more embedded across government. Almost every government department now has its own chief scientific advisor who bring their own specific domain expertise to the needs of the department. And part of my job was to lead the network of science advisors across government, and we would typically meet every Wednesday morning in my office, and from there I would go off to the Cabinet Office for a Wednesday morning meeting which brought together all the permanent secretaries across government, chaired by the Cabinet Secretary. And within a very short time of taking up the role in 2013, I encountered several issues that forced me to think extremely carefully about science and how scientific knowledge is applied, about risk and uncertainty, and about the challenges of where science meets human values. So the first of these was climate change, because the IPCC produced its fifth series of assessment reports in 2013 and 2014, and of course we've now seen the cycle turning again with COP26 in Glasgow earlier in the year. And then, as now, these attracted a great deal of political and public interest, and I found myself both dispatched to the Cabinet room to explain to the Cabinet, but also the TV and radio studios to explain what these reports stated and what were the implications. Now, by 2013, the scientific position on climate change was really very clear indeed. The evidence for global warming and that this is being caused by the anthropogenic emissions of carbon dioxide, methane, from burning fossil fuels was extremely robust. So why was the presentation of the evidence still contested and contentious? And the reason then and now is actually, I think, quite straightforward in a way. It is that if we're going to stop global warming, it requires a massive change in human behavior, which of course is to stop burning the fossil fuel that's powered the development of the modern world for the human species. Now, if you don't want to deal with the policy challenge, one way of ducking it is to reject the science. In other words, to say, the science is wrong, so I don't have to worry about policies to do anything about the burning of fossil fuel. And in my view, this is a very dishonest approach to the issue. I think the proper approach should be to acknowledge the results of the scientific research, which was unequivocal in 2013 and is sort of beyond unequivocal if that's possible, which it isn't, in terms of the human role in global warming. But what is the subject of legitimate debate is what policies we should implement to prevent, mitigate, and adapt to climate change. And I'll come back to this topic in a few minutes. And a second issue that confronted me was actually rather different because it required immediate policy decisions, but in the face of a great deal of uncertainty, incomplete evidence. And this particular issue belonged to a department called DEFRA, the Department of the Environment, Food and Rural Affairs. And this was the decision as to whether the government should ban the use of neonicotinoid pesticides. And there were really quite powerful and emotional forces, both for and against the banning of these substances. Not surprisingly, farmers were involved and environmentalists. And of course, the two are not mutually exclusive. So whilst they tended to be on opposite sides of the equation, it wasn't quite as clear-cut as that. And I have to say that some of the scientists took very strong and opposing positions themselves in the face of incomplete evidence, where scientists do sometimes tend to perhaps slightly over-promote the significance of their own research. So scientists are human, and like all humans, are not all perfect. And of course, these were the trade-offs. So farmers were faced with the potential for insects to devastate their crops. But of course, the other side of the equation is the use of these insecticides to prevent crop loss had to be considered against their potential to harm populations of pollinating insects, including amongst many species, bees, which have a particularly iconic and sort of emotional importance as the providers from ancient times of honey. And another part of the equation was that, of course, if neonicotinoids were banned, there was also a risk of substitution by other insecticides, each, of course, which also brought harms to insect populations. So how to advise government? The answer, in a sense, was both simple in principle, but quite hard in practice. Because, as you'll have gathered, I went to medical school, so I wasn't necessarily an expert in all of these domains. But the job of the DCSA was to assess rigorously and dispassionately what evidence existed and what were the uncertainties. And that's where you have to bring in the expert scientific community. So to do this, I commissioned a small group of scientists with first-class credentials for their expertise and their scientific rigor to identify all the available evidence and to produce an assessment report on all of the effects of neonicotinoid usage, and to sum up the quality of the evidence on both sides, so they scored it. And on the basis of those reports, policymakers decided that on balance at the time, the use of neonicotinoids was supported by existing evidence. But in light of all the uncertainty, it was also agreed to commission further research about these compounds. And of course, the research question is not whether neonicotinoids can harm and kill a wide variety of insect species under laboratory conditions. They absolutely can do. The real question is whether, when applied in the concentrations as directed on real farms in the real world, they harm species other than the intended target species. And it's clear that over the last few years, the evidence from these and other studies that neonicotinoids applied in the field do cause harm to a wide range of insect species has grown. So neonicotinoid use in the UK is now prohibited except under exceptional circumstances requiring licensing. Now, none of these are easy issues to deal with because, on the one hand, it goes back to the resilience of human populations. We need safe, affordable, and secure sources of food. But on the other hand, we are custodians of the planet for other species and the natural resources of the planet for present and future generations. And there's no doubt that one of the threats is that insect species are in decline. There's substantial decline in insect species in the UK. When you went for a drive when I was young, your windscreen would be plastered with insects that had been caught on the windshield. Now, your screen is clean at the end of a drive, and that just shows you what's going on. But there are other, well, that's a fairly objective method if you do it systematically, but there are plenty of other surveys that are showing evidence for a decline in pollinators. And of course, that poses huge threats, because many plants don't reproduce without pollinating species. So exposure to such highly contested issues within weeks of starting as GCSA drove it home to me how strongly scientific evidence and advice could become contested and contentious in areas where scientific evidence meets human values. It also led me to think more about issues of trust. And Honora Neal, the great philosopher, who has done an enormous amount of work on trust, points out that the corollary of trust is being trustworthy. And so it's critical that scientific advisors behave in a trustworthy fashion. And there has been a great deal of talk over the past few years on the topic of trust and who trusts whom. And there are lots of public surveys, and they typically show a high degree of trust in professional groups such as doctors and scientists. And at the bottom of the scale of trust are politicians and journalists who vie with each other as the least trusted. But I mean, to be honest, these surveys all miss the really important point, which is that trust is almost completely context-specific. So we may not trust a journalist who's writing about political matters or maybe the behavior of a pop star, or indeed about political parties seeking re-election. But we will trust a journalist 100% who's reporting the football scores. And we'll also trust a good constituency MP who, like a good GP, will have a high degree of trust by many of their constituents. And so trust is something that is absolutely context-specific. And I'd say exactly the same about technologies. It is completely pointless to ask whether GMOs are a good thing or a bad thing. They can be both. The question should be, what gene, what organism, what purpose? And that applies to all technologies, AI, We were talking about social media early. Well, social media can be a good thing if it's applied for good purposes, and it can be a very bad thing if it's promulgating falsehoods about vaccines, for example. And of course, the converse of this is that when a scientist talks on the radio about the Higgs boson, or about the wonders of the natural world, they will be absolutely trusted. And it amused me when the Higgs boson was described that the main critics of the people presenting it on the radio were other physicists who said it wasn't clear enough or they didn't get it quite right. Whereas my attitude was, well, if you feel that, you go and do it. I didn't try and communicate the Higgs boson. That was not necessary, fortunately. And by and large, the scientists who've been providing clear explanations of what's going on in the COVID-19 pandemic have been very well trusted. So scientific communicators on the whole have done very well, and actually journalists, certainly on the public broadcasting channels, have done very well, particularly the science, the medical correspondents. But, and it is quite a big but, scientists are much less trusted when they tell people how to live their lives. And that's when the science rubber really hits the road. Or indeed, when their science touches on issues where people have strong religious or moral beliefs and values. For example, issues such as assisted dying, embryo research, animal research, or genetically modified organisms. And so some people believe, conscientiously, that it's wrong to interfere with the sanctity of life or to fiddle with nature. And of course, people have powerful views about our relationship with the natural environment, which I think is a good thing. So we must recognize that trust is highly context-specific. And of course, going back to issues such as animal research, people are entitled to very different views, but the great thing about democracy is that we live in plural societies that can accommodate people with different views, and when decisions are made, then they are made through the democratic process, which is through government, parliament, and policy and legislation. And so you end up with an answer which not everyone will be pleased with. But trustworthiness is really important, and it is one of the reasons that, frankly, politicians do badly in surveys of trust, because sadly there are all too many examples of politicians behaving in untrustworthy fashions. But it's true of scientists too. So we're all human, and not all scientists are completely trustworthy either, sadly. But it is the essence of the scientific method that it depends on probing research, rigorous methodology, skepticism, challenge, peer review, which of course is scrutiny by experts. I think peer review sometimes gets confused. It is no more and no less than experts looking at things. And I think it's also true that progress in scientific knowledge also depends typically on many small steps that collectively build knowledge. So good scientists are honest about not only what is known, but also what is not and what is uncertain. And one of the things that I rather deplored as Government Chief Scientific Advisor is that we didn't value meta-analysis research synthesis more, because what policymakers is, they need to know about all the research. And so research synthesis is very important. But promotion criteria are very limited, usually to a particular sort of original discovery research. And there is a whole different topic on incentives for promotion and the perverse effects that these have, actually. So, but of course the need for skepticism has got to be weighed against the solidity of the evidence. So it's not sensible or valid to be skeptical about whether the Earth is roughly spherical, or indeed whether COVID-19 is caused by a coronavirus, or indeed whether humans are causing climate change. In each of these cases, the weight and the extent of the evidence are so strong that there are no reasonable grounds to be skeptical about them. And my PhD supervisor, Peter Lachman, who was a very distinguished clinician scientist, he became a vice president of the Royal Society, and he used to draw a useful distinction, in my view, between what he called polable or non-polable issues. And what he meant by that is whether it makes any sense to vote for the answer to a question or not. So it is completely meaningless to ask people to vote for whether planet Earth is roughly spherical or flat. It's meaningless to vote on whether COVID-19 is caused by a virus. And indeed, it's meaningless to vote whether humans are a major cause of climate change. There is actually a right answer to each of these questions. And actually, even if we weren't quite certain about it, it still wouldn't be legitimate to vote on it, because the scientific method will eventually uncover an answer. And the US politician Daniel Moynihan, I think, neatly encapsulated this by saying you can have your own opinion, but you can't have your own facts. But in contrast, and coming back to climate change, it's perfectly reasonable for people to have a say in what policies we support to respond to anthropogenic climate change. And here there are essentially three options on which people could be asked to vote. So the first is to do nothing, and that would be on the grounds that we really don't care much about future generations. It's not a position that I support, and I imagine many people in this audience would support, but it is a viewpoint. And it's just worth saying, actually, that we are very bad at thinking about future generations. And so research has been done on this. And if you use the economists' approach on working out what the discount rate is, we have a 0% discount rate for our children and our grandchildren, for very obvious reasons. We know them, we can touch them, we love them. If you ask people what their discount rate for their grandchildren's grandchildren is, it's 100%. So we're not terribly good at sort of loving future generations. And of course, 4 generations in the history of the planet is an instant. And so we're seeing very rapid change, which will affect the lives of, they're already affecting our lives, they'll affect our children's lives very much more, and their children's life an awful lot. So the second option, of course, going back to climate change, is to do everything possible at whatever price and consequences for the lives of present planetary inhabitants. And not surprisingly, the third option is to do something in between the first and the second options, which of course is what politicians around the world are doing. But then I think there's a really important question about whether the balance is fair between the consequences for present and for future humans and other species on the planet. And I'm afraid that the danger of the delays in making and implementing policies and the compromises that are being made are exposing future generations to extreme jeopardy. But the truth is, the policy decisions are made by the people that we elect. And here I think there's another important point, which is the danger of the old voting against the young. And I think we've seen that all too often. So there is a very important difference of views and values between the young and the old. It is the young that will reap the worst consequences of unmitigated climate change in comparison with the old. But of course, the demography of many of our Western liberal democracies favours the old, because we, and I count myself as old now, though I try to vote in favour of the young, are a larger fraction of the population and are more inclined to exercise our vote. So it's really important to encourage greater democratic participation by young people. And of course, a university is one of the most important places that we can do this, but it matters in schools as well. There's nothing more important, I think. And of course, at the most minimal level of participation, casting a vote comes with minimal effort and opportunity costs. So we must defend democracy. There are other areas in which science, engineering, and technology come into conflict with human values. So we are a species that dislikes perceived unfairness. And so if the benefits of research discoveries are realized for some people and not for all, this definitely can cause significant problems, which can manifest as a mistrust for science, engineering, and technology. So an important and timely example is vaccines, how they're distributed and made available. They're certainly the most important tool in our defense against coronavirus infection, and they've already had a transformative effect in countries like the UK and Canada. But one of the most striking effects of the coronavirus pandemic is that the most serious consequences have been borne by the most economically and socially deprived people within communities, towns and cities, and across different countries around the world. And the distribution of vaccines in the UK has been one of the greatest successes, which has been contributed by science and its operationalization by the NHS. And it's one of the really important issues that actually improving the logistics of healthcare delivery systems, I think, is a really important thing where there's a lot to do. But nevertheless, it hasn't stopped the worst burden of the disease in the UK being felt by the least advantaged in society. And across the world, billions of people have not yet received the benefits of vaccination. And whilst the AZ vaccine has been made available, thanks to the values of the company AstraZeneca and the scientists in Oxford behind the vaccine, they provided it at cost. And of course, the cold chain meant that it was easier to distribute. This isn't the case for the Pfizer and Moderna vaccines, whose cost is beyond the reach of the poorer countries of the world. But this is just one example of very many. The benefits of new science, engineering, and technology that we take for granted are distributed unequally across the world, leaving many of the poorest countries and people deprived of those benefits. There are other examples of where unfairness, either perceived or real, plays an important part in people's perception of science, and particularly its application. And broadly, they can be labelled my pain, your gain. And this applies particularly to infrastructure projects. So even the most ardent advocate for low-carbon green energy may change their colours if there's a proposal to build a wind turbine in their backyard. Nuclear energy ticks a whole string of boxes when it comes to the conflict between science, engineering, and society. For some people, there is something mysterious, unnatural, frightening, and evil about just radioactivity and radiation. It is seen as this invisible, toxic miasma. But then there's also the specific fear of nuclear power stations themselves, which at one level are just a vast piece of engineering physical infrastructure that dominates a locality, and in another context evoke the images of Chernobyl and Fukushima. But the truth is, the evidence shows that nuclear energy is substantially safer and greener than fossil fuels. The mining of coal and its burning have killed many millions of people across the planet, and this is a major threat to the health, well-being, resilience, and security across the planet. A minute number of people, in comparison, have been harmed by civilian nuclear power. But the fact remains that nuclear energy is one of the least trusted technologies, in spite of the fact that it could have an important part to play in decarbonising our power supplies. The final major area where science meets society with strongly contested outcomes is in the context of uncertainty. And here again, there are three possible responses faced with an application of science through technology that offers the probability of benefits, but is also accompanied by uncertainty about possible risks. So the first approach, and it's a bit similar to climate in a way, is to throw caution to the winds and get on with the beneficial application. The second is to apply the so-called precautionary principle and to refrain from the application altogether, with the risk, consequently, of missing out on all of the potential benefits. And of course, the third is to take the middle ground, which is to apply the science, but in a regulated and cautious way. And of course, this third pathway is the established approach in medicine to the introduction of new drugs and other therapies and diagnostics. And most countries operate similar systems of regulation, and medical science has introduced rigorous graded clinical trials to establish and measure objectively the benefits and side effects of new interventions. And even after it's deemed safe to introduce new treatments, these can typically only be prescribed by licensed practitioners, and there's long-term reporting of adverse effects. But processes such as these are the exception rather than the rule in the introduction of new technologies. They're also enormously expensive and are one of the factors that limit the widespread availability of new treatments across the world at affordable prices. And of course, the current technological revolution that's transforming the lives of people across the world is the digital revolution. And at the bleeding edge of this are digital cryptocurrencies and artificial intelligence. The former, of course, has bypassed national banks and regulation and provides a global currency that's largely unregulated and is undoubtedly a major vehicle for illegal trading. Though the recent ban on trading using cryptocurrencies in China may be a harbinger of the future. AI is certainly here to stay, and we could debate many hours the potential benefits and harms of AI, but we won't today. But this is yet another example of the inevitability that any new technology carries the possibility of beneficial and harmful effects. So the discovery by our ancient ancestors of how to harvest the benefits of fire is an old example. Were there debates about whether the use of fire should be banned because it could burn people? I doubt if the benefits of warmth and cooked warmed food were contested by those worrying about the ill effects of fire. So the question for any new technology is not, is it a good thing or not? Rather it is the use of the technology for this specific purpose, in this particular fashion, acceptable? Every new technology creates its own Pandora's box. Personally, I don't think we should try to slam the lid shut, nor that we should stop discovering new things because the potential for future new technologies to cause harm is so uncertain. But nor should we ignore the potential risks of new technologies. We should be thoughtful. We should be open about their potentials, both good and evil. And most of all, I think what we should do, what we're doing this afternoon, which is to discuss and debate how the discoveries of researchers can be applied most effectively for the benefit of society and how we might avoid their potential misuse. I look forward to your thoughts and questions. Thank you for your attention.
Very comfy. So thank you very much for a very stimulating and very, very interesting lecture. I think you've covered a very wide spectrum of things, but the part that really grabbed me was the fact that you had to engage on a regular basis with the danger of politicians. You had to be in close contact with them. And I don't know if you kept a meter distance or whatever, but I got the impression during the worst parts of the pandemic, at least here in Quebec and in Canada, that when you combine science with politics, you got politics. And I wonder if you could comment a little bit on, at least here, we didn't have, of course, 10 Downing Street, but we had our local prime minister coming out with his advisors on daily or multiple times per week, giving us the sense that people were really confident about the COVID-19 and so on. And they were making some really good decisions. They were also making some really dumb decisions. So I'd like you to expand a little bit on that while my colleagues get up to the microphone to ask questions.
Well, I mean, I suppose the first thing to say is that it is just the nature of democracy that the people who make the decisions are the politicians. We elect them, and if we don't like them, then we have the option to elect someone else. So ultimately, there are inputs to politicians, and actually one thing I think I didn't say is that when politicians make a policy, when policymakers, they look through three lenses. They look through the lens of what do I know about X or Y? That's the evidence question. They look through the lens of if I deliver this, is this policy deliverable? Because people always come out with wonderful ideas of policies which are utterly undeliverable. And the third lens they look through is the lens of their values, their personal values, their political values, the values of their friends, and the values that they perceive of their electorate. And it's those values that often trump the first two. And that is just the nature of policymaking. And it was something that actually David Hume wrote about in the 18th century. So I think that, I think the other thing is that, of course, you can look at the science input on its own, and certainly the role of the Scientific Advice Group in emergency in the UK was to look very much through the lens of this is the pandemic, these are the effects of the infection. If you want to stop the infection spreading, these are the things you can do. And it was often said, well, why don't you have, you need economists on the committee, you need other social scientists, you need educationalists. No, that's not the right answer, because it's the job of the politicians to integrate all of those different inputs and make the decisions based on them. It's not the job of the scientists, as it were, the sage advisors, to make the decisions about those trade-offs. Because, of course, the challenge from the beginning was there are other health consequences of the pandemic. So there's a set of health consequences around people not seeking healthcare for other conditions, cancer, heart disease, etc. There are the health effects of social isolation, being stuck in a high-rise flat on your own with small children, for example. There are the economic effects of loss of jobs, which is very awful for people. There's loss of education for children. I mean, again, the young have sacrificed quite a lot for the old in the pandemic, because actually the young have really not been susceptible to the worst effects of the disease, whereas my generation and older have been. So these are the trade-offs that the politicians have to make. And, frankly, it's much easier to be a science advisor than it is to be a politician.
I think that's a fair comment. I don't know if anyone has any questions, please go up to the mic. I was intrigued by, while we're waiting for that, I was intrigued by your statement that we should not be talking about STEM, but about STEAM. And I think you just alluded to it in your last answer. I wonder if you could expand on that a little bit, because there is a reluctance among discovery scientists, in my experience, to take seriously the social sciences and the humanities and their potential contribution to the way we do things. And yet, as a doctor, and certainly as a dean of a health sciences school, I've seen more and more the critical importance of social factors, of all the issues that you raised. So how does one convince our colleagues that this is the right thing
Well,
to
I
do?
think I'll answer it in two parts, actually. So firstly, it's wonderful that we've got vaccines, but they are absolutely no use if they're in the syringe and not in the arm. And so understanding why it is that some people are vaccine hesitant or anti-vaxxers, I mean, it's actually a very tough, it's what social scientists would call a wicked question. It's a very difficult one to solve, actually. But that's a question for the social sciences. And a concrete example where social sciences contributed very substantially was in Ebola. So it turned out in the Ebola epidemic in West Africa that funerals were an important event that caused transmission. And the explanation for that is that the cultural practice in West Africa was that at a funeral, it was customary to pay respect to the corpse by touching it. And unfortunately, Ebola transmits most when someone is very, very sick or immediately after they've died, because they're still covered in the bacteria, or the virus, sorry. But simply saying to people, mustn't touch corpses, I mean, that was a terrible thing to say, actually, because it was so culturally important. And so anthropologists came up with ideas about how you could substitute other respectful practices. But the other point I'd make is that I think there's something very important about how we actually educate scientists and people in the humanities, actually, which is that we tend to treat a university course in chemists as a vocational education. In other words, our eldest daughter went to university to be a chemist. All her friends said, you're going to be a chemist. And actually she is. If she'd gone to read history, they wouldn't have all said, you're going to be a historian. And so, unfortunately, and it's the people that educate, I'm afraid, the scientists that are most guilty of this. They tend to view almost any output other than being a scientist as somehow being a failure. Whereas historians possibly view, they were jolly good they did history, but actually they lots of opportunities outside. And if we want more scientists in politics, then we've got to, I believe, start training scientists as a vocational education for life. And if you look at the qualities that are needed in a researcher, and I mean a researcher broadly, they are numeracy, skepticism, rigor, the ability to communicate effectively. With those skills, the world is your oyster. Almost any job is possible. And yet, we have scientists who somehow believe it's beneath them to do all these other tasks. And so, I mean, fundamentally, I have no sympathy with scientists that are disrespectful of people doing different things. I think it shows a limited worldview. Apologies to whoever I've offended, either online or in the room.
Well said. Professor Burke has a comment.
Actually, the question I had was along those lines, because earlier today we talked about not just the impact of science on policy, but more broadly. So just to continue on this topic of scientists doing other things, I mean, what should we change to facilitate that? So is that really just personal choices by scientists, or can we really do things to encourage this?
One can do an enormous amount to encourage it, because we all respond to role models. So, I mean, this really is an educational issue, I think, in schools, but also in universities. And funnily enough, it's probably sort of slightly the opposite way. In schools, we need to get more science, actually. And the problem there is shortage of science teachers, because, kids are very enthusiastic about science. It's really interesting. And the thing that actually probably influenced me more than anything was actually practicals. It was a term of experiments in biology on the genetics of Drosophila that changed my life. I can't tell you anything else about the biology syllabus for my exams at school. I can tell you, and that project was pretty relevant to it. That changed my life. And I learned about statistics, I learned about Mendelian genetics, I learned about all sorts of things. So I think at school, and it comes back to, if you like, a broad education that educates people in the humanities and the sciences, so that C.P. Snow, as it were, can stop turning in his grave. And then at the university level, I think it's the other way around. I think there, the science teaching needs to be a much broader education. And I think that applies also, to some extent, post-PhD as well, because a postdoctoral career is seen by many established sciences as the route to become an academic, whereas actually only a fraction of postdocs will become academics. But we don't, I think, provide enough. And I think it's changing, so I need to be careful. But I think we need to be absolutely sure that we provide the sort of continuous professional development to postdocs that enables them to move into other walks of life. So in Whitehall, for example, on the one hand, actually, there are a great many deep science, engineering, technological, social science specialists. There's the economists in the Treasury, and the work in ensuring the security of citizens involves a lot of science and engineering. But nevertheless, amongst the policy professionals in the civil service, a relatively small proportion would have had a scientific or mathematical background. And again, the thing I discovered was that the civil service offered an array of absolutely fascinating careers and gave quite young people an enormous amount of responsibility at a relatively early stage in their career. And I suppose it goes back to probably the best piece of mentoring advice I had from my PhD supervisor, Peter Lachman, when I was faced with a choice as to what to do next after I'd finished in his laboratory, to stay in Cambridge or to move to Hammersmith. He said, well, careers can't be planned. And actually that was quite useful. I took that advice very seriously, as you can tell. But I think it's important. So science is an education for life.
I think on those wise words, we're going to draw this to a close. I want to thank you all for your attention. I want to thank you for absolutely fascinating presentation and great answers to the questions. And with that, I'm going to ask Albie Angel to say a few final words that he's asked to do.
Thank you. Thank you very much. It gives me great pleasure at this junction, coincident with Sir Mark completing his term as 2020 Friesen Prize winner, to announce the 2021 Friesen Prize winner. It is Dr. D. Lauren Terrell. Friends of CIHR is pleased to announce that Dr. David Lauren J. Terrell, Distinguished Professor at the University of Alberta, visionary clinician scientist, creative virologist, and entrepreneur and academic leader, is the recipient of the 2021 Henry G. Friesen International Prize in Health Research. I won't read his complete bio, which is fascinating, but just to remind you that his most celebrated life-saving accomplishment in collaboration with Morris Robbins was the licensing of the first oral antiviral drug for chronic HPV, lamivudine, in 200 countries, and then subsequently to note that he maintains an active research program in viral host interactions and development of Hep C vaccine and an active program of SARS-CoV-2 vaccines, diagnosis, and antivirals. He's published over 250 peer-reviewed papers, and in his spare time, he looks after 1,000+ acres in Alberta as a farmer. This is 2021 Henry G. Friesen International Prize winner, David Lauren Terrell, with significant nominals and significant accomplishments. And that's special announcement number 1 for all here. He's looking forward to coming here sometime in the new year. And the next slide, if I may. I just have to go back. This week will be my last opportunity to formally communicate from the podium as president of Friends of CIHR. I will be retiring at the end of this year. This is after 24 years. I hear cheers, yes. It's my good fortune that the Succession Planning Committee of Friends, chaired by Dr. Bruce McManus, successfully engaged an exceptional successor to lead the organization beginning January 1, 2022. Delighted to introduce to this audience Dr. David Malkin as President-elect Friends of CIHR. Dr. Malkin is a professor of pediatrics and medical biophysics at the Temerity Faculty of Medicine at the University of Toronto. He's a clinician scientist, a cancer physician, and an academic leader at the Hospital for Sick Children. He is the CIBC Children's Foundation Chair in Child Health Research. Dr. Malkin's extensive research program is focused on genetic and genomic mechanisms in childhood cancer susceptibility. I know that Dr. Malkin is eager to continue the tradition and introduce future Friesen Prize winners to McGill University. Thank you very much.
Well, this marks the end of our festivities. I want to thank everyone for being here. Mr. Mark for a fantastic lecture and wish you all a great rest of the day. Thank you.